Hello everyone. In the previous video, we just saw the introduction to binomial distribution. In this video, we will try some of the numerical problems on binomial distribution. The first one is question number 22, which read as, based on experience, the quality control engineer of Heavy Electrical Limited has estimated that the probability of commissioning each project in time at a client site is 0.9. It should be is 0.9. The company is planning to commission 5 such projects in the forthcoming year. Find the probability of commissioning. No project in time, 2 projects in time, at most 1 project in time, at least 2 projects in time. Primarily, in the question number 22, subsequently I would have written binomial distribution. First of all, this question has not given you like it is following a binomial distribution or what. Nothing is given. But it is, we are going to use binomial distribution. The reason is what? One is that they had given you, if you look into this, probability of commissioning each project in time. So that means I can define a random variable. Let capital X equal to random variable denoting commissioning of projects in time. That we are going to call it as a capital X, number 1, because the question talks about that. Then the question also says that based on the past experience, this quality control engineer has already identified the probability of success, basically commissioning everything in time is 0.9. So I can say probability of success is already identified. Probability of success is already identified as 0.9 by the quality control engineer. Then the question further says the company is planning to commission 5 such projects in the forthcoming year. That means they are going to do some commissioning of 5 new projects. Means it becomes the number of trials. So number of trials, what is going to happen? Here we are considering the number of commissioning as the number of projects as, or I can say number of trials or number of projects is 5. So I can definitely call this probability of success as smaller p, number of trials as smaller n. So one is that we have n value available, that is number of trials available, probability of success available. These are the 2 parameters of binomial distribution, n and p. Because once I know p, I can very well find out q, because q will be your, I can say, let me write it here itself. Q is 1 minus of p, which is 1 minus of 0.9. So I can say q is, that is probability of failure is 0.1. We can say that. Sorry. So we can say that as 0.1. Right. So if I have n value and p value, I am getting the 2 parameters what is required to do with the binomial distribution. Secondly, a project, if it is commissioned in time, that is considered to be a success. If it is not commissioned in time, it is considered to be a failure. So there are, in this question also, there are 2 mutually exclusive and exhaustive events possible, right? So that is one of the assumption of a binomial distribution, one of a condition of binomial distribution. 2 mutually exclusive events means one is success, another one is failure. right? Then if you look into, if I do the probability of success is predefined, means based on past experience, it is already there. So that means even in future, this will not change. It will remain the same. The probability of success will remain the same. That is supposed to be the second condition for a binomial distribution. That is also satisfied. Yes. Third one, just because if the first project is successful, that doesn't mean that the second project also will be successful. Or I can say just because the first project is successful, the second project will be a failure. It can be again a success also. Means every time when I start a new project, it is completely independent of the other projects. Means every trial or every project is independent of each other. So all these three conditions which are meant for a binomial distribution is getting satisfied. So that is why this question, after giving the number for the question, I also wrote binomial distribution. Means we are going to use the binomial distribution only. So next subsequent slide, I will say it is clear that 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 capital X follows. What is capital X? That random variable. If I put like this approximation symbol, it indicates here follows, X follows capital B. Capital B denotes binomial within brackets n comma p. What does it mean? X is following a binomial distribution which has got a parameters n and p. Already we wrote what is n, what is p. So therefore I can say probability of X taking the value small x should be equal to NCX. I am writing the probability mass function of a binomial distribution, which is already written in the theoretical part. NCX p power x q power n minus x. X takes the value 0, 1, 2, and so on up to n. So in this case, what it is? In this case, probability of X equal to X will be, we already know number of projects is 5. So n is taking the value 5. C X. What is success rate? It is 0.9. So probability, this p value is 0.9. Then to the power of X. What is Q? Already we calculated it is 0.1. So 0.1 power 5 minus X. And X is going to take values now 0, 1 up to 5 only, because there are only 5 projects we are expecting. Now, what are the questions? The first question is no project in time. Means we are supposed to find out what is probability of X is equal to 0. That will be 5. Just substitute small x for 0. 5c naught 0.9 to the power of 0, 0.1 to the power of 5 minus 0. So 5c naught is 1 because NC0 is 1 only. 0.9 to the power of 0 is also 1. So ultimately we have 0.1 to the power of 5. That works out to 0.0004 zeros and then 1. That will be the probability of no project successful. First one. Second question. 2 projects in time. So what is probability of X equal to 2? Substitute wherever small x is there in this function, substitute small x for 2. So 5c2, 0.9 to the power of 2, 0.1 to the power of 5 minus 2. 5c2 means it is 5 into 4 divided by 2. 0.9 square is 0.81. Then this is 0.1 to the power of 3. So I can write 0.1 to the power of 3. So it is 0.01. If you calculate this, how much do we get? That works out to, this will be 10, isn't it? This ultimately it is 10. So we have now 0.0081. So that is the required probability for the second question. Now, what is the third one? At most 1 project in time. Let us move on. At most 1 project in time. means maximum one project in time. So that means this X has to be less than or equal to 1 at most. At most means maximum one project in time. So since it is at most, I have to consider it as less than or equal to 1. So I can write this as X is equal to 0 and X is equal to 1. X is equal to 0 already we found. We found that as 0.00001. We can copy that. 4 zeros, yeah. Then probability of X is equal to 1, we need to calculate. So we will substitute 5C1 and then 0.9 to the power of 1, then 0.1 to the power of 5 minus 1. So that will be 0.00001 plus 5C1 is 5, 0.9 is power 1 is same thing only. Here it will be 0.0001 because it is to the power of 4. So that ultimately this works out to 0.00046. That will be the desired or required probability. What is the fourth question? At least 2 projects in time. At least means minimum 2 projects in time. So I will write greater than or equal to 2. Now greater than or equal to 2 means I have to calculate for 2, 3, 4, 5. That means I have to calculate 4 different probabilities. For 2 we have to calculate, then 3, then 4, then 5. So 4 different probabilities. Instead what I can do, I can go for a complement calculation. So I can write this as 1 minus of probability of exactly opposite of greater than or equal to will become less than 2. Again, when it is less than 2, 2 is not inclusive in this. 2 has to be excluded because it is less than 2. If it is less than or equal to 2, then I can consider 2. But here it is only less than, so that means 2 is excluded in that. That means I can rewrite this as 1 minus of probability of X less than or equal to 1. I can consider 1 also, and I can consider anything less than 1. Why I am doing that? So that I can substitute this value. So this will be what? This will be 1 minus of 0.0046. So if you calculate, that will work out to 0.999 and then is it 54? Yeah, 54. So I think there are 4 questions. We did all the 4 questions, right? We will now move on to the. So the next question is question number 23. Let us read the question. The probability of a shooter hitting a target is 3/4. Okay, that means probability of a success. Hitting the target, if it is considered to be success, I'll say hitting a target is considered to be a success, right? That is given as 3/4. Now, how many minimum number of times must he fire so that the probability of hitting the target at least once is more than 0.99? So here also we can use binomial. Why? Because one is the number of, the probability of success is known to be 3/4. So let me write that. Probability of success. Success means hitting the target. Hitting a target. That is given to be 3/4, which I will call it as small p, which means our Q, it will be 1 minus of p. So it is 1 minus of 3/4. So that works out to 1/4. What is that? It is probability of a failure. But we don't know how many times, how many minimum number of times he has to do. So let the number of trials, we'll assume it as n, right? But again, we are assuming it as binomial because one is probability of success is known, but we don't know what is the number of trials, but still we are considering it as binomial. Reason is that the same logic, we have seen that all the 3 conditions are satisfying here, because you have either you hit it or do not hit it, means there is a success or there is a failure. There are 2 mutually exclusive and exhaustive events possible in this, number one. Again, every time when you shoot, it is independent. Every trial is independent. That is also satisfying. So on those basis, we are considering this as a binomial distribution. So if I consider that as a binomial distribution, I will have, so what is capital X? Let capital X equal to hitting a target. Number of times of hitting a target. Number of times of hitting a target. That we are going to consider it as yes. So it is obvious that X follows a binomial with n comma p. Now I can write the probability mass function. X is equal to X will be NCX p to the power of X q to the power of n minus X. In general, I'm writing 0, 1, 2 up to. Now for this problem, let us be very specific to write in the next slide. Probability of X equal to X will be NCX. What is P? It is known to be 3 by 4. So 3 by 4 to the power of X, then 1 by 4 to the power of n minus X. Now what is given in this? In this, they gave you probability of hitting the target. Hitting, let us read that. The probability of hitting the target at least once. Probability of hitting the target at least once. What is given is more than 0.99, is greater than 0.99. That is what is given. So what is this exactly? It is actually speaking, hitting the target at least one means X larger than 1. That is given as 0.99. At least means it is not only greater than, it is greater than or equal to 1. Yeah. Now, how do I take a complement of this? Complement of this will be 1 minus of prob, because I don't know what is the n value. I don't know how long I will go. That is the reason I'm going for a complement of it. So X less than 1 is greater than 0.99. That is what it is. Now, when it is less than 1, that means 1 is excluded. So you have only 0. X equal to 0. That will be greater than 0.99. Now, I can rewrite this as 1 minus of, what is probability of X is equal to 0? Let me substitute X for 0 in the above function. Means n C naught, okay, then 3 by 4 to the power of 0, then 1 by 4 to the power of n minus 0, that will be greater than 0.99. So again, how do I write it? It is 1 minus of, this value is 1, this value is also 1. So 1 into 1, it will be 1 only. And here you will have 1 by 4 to the power of n. This is greater than 0.99, right? So how can I do that? I can bring this 0.99 to the left-hand side. It will become 1 minus 0.99 is larger than 1 by 4 to the power of n. What is that further? It can be written as 0.01 larger than 1 by 4 to the power of n. Now this, what do you call? I can do a cross multiplication, which I can say like 4 to the power of n. I mean, I am taking like this, cross multiplying this. 4 power n will be larger than 1 by 0.01. What do you mean by 1 by 0.01? It is nothing but 1 by 100, which is nothing but 100. Means 4 power n is larger than, that means that 4 power n is larger than 100. Then what is the minimum value of n? What is possible? 4 power 1 means it is 4 only. It is definitely not larger than 100. 4 square 16 is also not larger than 100. 4 cube, it is 64. not larger than 100, but 4 power 4, because n can take only integer values because it is number of trials. It can't take any decimal values. So that means the n value or the minimum n value is minimum number of trials should be 4 only, because 4 to the power of 3 is 64. That is not larger than 100. But if I multiply one more 4 with 64, it will exceed 100. So n should be 4. That is the answer for this. Yeah. So that is about this problem. Then we will proceed to our next problem. Let us read the next problem. Question number 24. If the probability of a defective bolt is 0.1. Remember, it is not the question of it is a good bolt or defective bolt and all those things. Whatever probability is specified, it means that you have to take it like this. Like if I could able to identify a defective bolt and segregate it, by chance also it will not go to a customer. Either I may do some rework or something like that, or I will segregate it. It is not going to my customer. That means it's a good thing. I can say that identifying a defective bolt is also a success, because wrong material will not go to the customer. So I can directly call this as probability of success, which is P, is known to be 0.1. I am considering the probability of identifying a defective bolt as a success. Now find the mean and standard deviation. We are supposed to find what is mean, right? And then what they had given, we have to find out mean, and then we have to find out standard deviation. Okay. Of defective bolts in total of 900. That means they had given you the total trials, total checks or total inspections, what you need to do. That is N, number of inspections or number of trials. You are going to check those 900 bolts. Since N and P are available, we will consider the mean of a binomial distribution. Mean of a binomial distribution is N into P. Standard deviation of the binomial distribution is square root of N into P into Q. Now N into P means it is 900 multiplied by 0.1, which works out to 90. And what is standard deviation? It is square root of N into P. Already we have, it is 90. This value we have 90. What is Q? Since we have P available, Q will be 1 minus of P, which is 0.1 or 0.9. So I can put Q as 0.9. So what is that? It is square root of 81. That means it is 9. So the answer is 9. So in case if you find the contents of this video to be useful to you, I request you to please like, share and subscribe. We will further see in our next video some more problems on binomial distribution. Till then, take care. See you all. Thank you.